What we want to talk about today is about segmentation. I'm not going to try and analyze all of IEC 62443. In fact, I'll try not to say that IEC 62443 more than 10 times in the whole presentation, but we'll see how many times I end up saying it. Because what we really want to talk about is segmentation and how that comes out in the zones and conduits requirements of the specification. One of the things that we've seen as we've talked to customers and prospects and people who have struggled with this particular technology is there is a better way than what we're seeing being attempted today. So that's what we want to talk about. So if you're on this webinar, obviously you have an interest in this. You may not be in manufacturing, which is really where people tend to associate the IEC specifications with. But if you take a step back of what they're trying to accomplish with Industry 4.0, it's to create a smart infrastructure. Now, that smart infrastructure, it could be cities, it could be water, it can be oil and gas, it can be any of the operational technology networks that are present in the networks today, which we consider critical infrastructures. And you want to do that connectivity to make them more productive, efficient, and flexible. That productivity is all about the connectivity. We talk about security and cybersecurity and zero trust and all the buzzwords around security, but sometimes we forget that the fundamental thing we're trying to do is connect device A to B. Security in its own way is designed to not let you connect to point A to point B unless you're supposed to. So that challenge of how do I let things connect, whether they're smart or dumb, as it may be in the device case for networks, to give me a more productive and efficient process. And again, often one of the problems here is that security gets in the way and actually makes things less efficient. So that's really important when we talk about segmentation, because the knock on segmentation today is often that it does make things less efficient and it's too complicated. So with the Industry 4.0 in mind, and we think about the standards, they're really designed to address security for OT technology inside of industrial control systems with automation. So that security talks about a lot of different pieces. And again, I'm not going to try and analyze the whole specification because many people could do that far better than I. But what I want to do is focus on one of the goals of that is to reduce risk, or manage risk, maybe is a better way to put it, and reduce it to a tolerable level based upon the desired security level. There are a lot of security levels inside the specification based upon the level of sophistication that it will take to get to that particular device. So if you have it, for example, someone can get in with very little knowledge and expertise, all the way down to require someone who really knows what they're doing to get into your network and to penetrate, et cetera. So at a very high level of capability, which means that they can do a lot more damage. One of the challenges to keep in mind in today's environment is we think about high school students or hackers sitting in their basement playing around. When you introduce things like generative AI, ChatGPT, and its bad offspring, things like worm GPT and such, you don't need as much knowledge about coding and vulnerabilities as you used to be able to get to these systems. So the level of capabilities of the people coming after your network today are higher than they ever were before because of this automation on the attack side of the house. And frankly, the defense side of the house has not yet caught up to that. So what we want to do is say, how can I, as an OT asset owner, reduce the risk of A, someone getting into my network, and B, if they get into my network, which is really what segmentation is all about, reduce the amount of damage they can do based upon where they get in and how they get in, et cetera. And that's what zones and conduits are about. And when you think about that environment, there was the recent report that came out from the SANS Institute on the state of OT security. One of the things they identified was that last year, in the past 2 years, I would say actually, a lot of the investment in the OT space has been around network monitoring, understanding what's happening on your network and the threats that are coming in, et cetera. But this year, there's been a sea change in terms of the shift of the focus. And now that people understand the threats that are coming after them, they actually need to stop those threats in the network. So one of the key indicators that came out of that SANS Institute report was that 95% of the OT leaders who responded to their survey ranked network protection as one of their top 3 investments for this year. And why is that? Well, if you watch the news at all, you know why. And it's because that over 50% of the attacks out there now end up on OT network owners or the OT networks themselves. Manufacturing is the highest attacked industry overall. When you add things like oil and gas, water, power, kind of the OT space specifically is over 50%. The reason being that those are valuable networks. If you're a manufacturer, for example, every minute that your network is down means you're not generating product, so you're losing money. If you can't get product on shelves, you're losing shelf space and you may never recover from that. We saw what happened in the Colonial Pipeline when the life cycle of oil and gas delivery was affected, the pain and agony that caused, and there's been a big spate of water attacks over the past year. So these networks are vulnerable and they need to be protected in ways more sophisticated than they have been in the past. And the reason that segmentation is important is because, again, in the same report, the SANS 2024 State of ICS, they identified that the top vector for attacks into OT and control systems are someone gets into the IT network and they can just get right into the OT network as a result of that. So that lateral movement, which is really what segmentation is designed to prevent, is the biggest problem out there. I have seen other reports, I think IBM might be the one that I'm thinking of, that said, leakage from IT into OT was 75% of the attacks. So there's a huge amount of problem introduced by the IT vulnerabilities, often credential theft, which is another very large conversation. But that is a problem that segmentation can really help you manage the risk should that happen. And that's what we want to talk about today in terms of how you can do that. For those that haven't read the IEC 62443 specification, the concept that is put out in there is something called zones and conduits. A zone basically says, I'm going to group the systems that need to talk to each other, or from a functional, logical, physical, safety, security, et cetera. I'm going to put those into a common group so that I can allow them to talk. And if someone wants to enter that zone or leave that zone, I'm going to basically evaluate what they're doing on a basis, on a person by person or traffic by traffic or whatever metric you have between them. And that decision on whether someone can enter or exit a zone is based upon the conduits, which connects essentially these zones between that. And as you can imagine, just by reading this, and we'll show you some diagrams here in a bit, that can get complicated when you think about how can I navigate through these zones with the right conduits. And as a security administrator for that, how do I configure all of these policies correctly so I can get from point A to point B on my network? And that is the challenge. And when we talk to customers, and Joe can certainly testify to this at BlastWave, when we talk about segmentation, you will either hear, oh, we've got some segmentation, which we'll talk about it on the next slide, but we often hear, oh, well, we looked at doing segmentation, and to segment my network will take way too long and cause too much downtime. We've actually heard times as long as 2 years of segmentation because of the downtime. And OT networks are designed to run 24/7. They're not supposed to go down. Scheduling downtime on power or on water networks is not something you want to expose people to. And in the manufacturing space, every minute of downtime, you're not making money or product. So having to enforce downtime and complications on those networks is a problem. So when you hear the segment my network will take too long and cause too much downtime, let's look at the people who have actually tried. How are they doing it? And that SANS report again talks about the number one way, about a little under half the users are trying to use things like firewalls to create those segments and zones and conduits. Some are still trying to use air gaps. There's some shared networks. There's some only electrical and mechanical can pass. There's converged logic and safety and other. So there is a lot of ways people are saying that they're doing segmentation. When you dig into it, often it may not be what you think. In fact, another answer we get when we ask, okay, well, tell us about the segmentation that you've implemented. Well, we have a firewall between our IT network and OT and a DMZ. It's kind of like the Purdue model. We have a layer 3.5 DMZ. And okay, now how are you segmenting inside that OT network? Oh, well, we're not doing that. And the reason is because it's too hard. But what we want to talk about today is that there is a better way. And it's important when we talk about segmentation to recognize that this is not an all or nothing concept. This isn't something where I'm going to wake up one morning and suddenly my whole network will be micro-segmented down to the device level. The goal is an iterative process where you want to get it better and more tuned to the needs of your business than you were yesterday. That's the goal. Not that you're going to flip a switch overnight and suddenly you're there, but it's make a little bit of progress every day. And although that sounds complicated, if you take a look at what people are actually implementing in the SANS report, so they did say that, in use, 66% of people say they have done segmentation between control and higher risk. 21% says they have planned. And what we want to talk about today is about software-defined segmentation, and specifically with BlastWave, zero trust software-defined segmentation. 40% of the people say they are doing that today. Again, how they're defining software-defined segmentation is to be determined, and only you can answer that for yourself. And 18% say they're going to investigate it. But what we want to show you today is how software-defined segmentation differs from the other methods and how that could benefit you. So what I'm going to do now is I'm going to turn over to Joe to talk a little bit about the options for creating zones and conduits. So Joe's going to talk about this, and I'll turn it to you, Joe, and feel free to just tell me whenever you want me to move slides for you.
All right. Well, hello again, everybody. This is a very interesting subject because even though we see the reporting, such as in the last chart, it really appears to me like when you get right down to into the weeds of the issue and get down to the details, that many times what people define as software-defined networking, I mean, we're talking about some very, very basic. We've bandied about different terms. There's segmentation, there's macro segmentation. Of course, blast shield goes all the way to micro segmentation, but surely there's some other levels in there somewhere, centi and milli and all kinds of other types of segmentation. And when you think about that, it's really kind of applies to the zones and conduit idea. Now, if you take a standard diagram kind of like this, in the different sectors and the different OT worlds out there, you're going to see things grouped in a number of different ways. And I think that the very first operation is this kind of a top-down, almost paper exercise of how do I group these assets? How do I group these devices or these cyber assets into something that just even approaches some type of rationality, whether it's by manufacturer and then down below that in manufacturers as far as endpoint like PLD, RTUs, or whatever it might be, SCADA servers, that kind of thing. There's going to be zones with security and surveillance in it, oftentimes running intermingled with these types of devices inside plants because networking resources aren't infinite. You're not going to have 45 different networks in parallel with only a few devices each. Nobody has that type of time and expense or money to lay out. So you've got oftentimes these great big piles of assets, and you're trying to group this into something that makes some kind of rational sense. So if you're looking at the diagram here, the ordinary way of doing that, once you get these groups made, even if it's on paper with your, as you see, like in these three different sites, the main site, there's a SCADA and thin client, and the remote site, there's SCADA and thin clients. And, and, uh, and then you've got different types of zones and things like that in there, but ordinarily what you would see in just about every case would be hardware firewalls. Now, Cam, wouldn't you agree with that you would see a lot of times just a bunch of firewalls, every different zone, every different group would have a firewall? What's
Yeah,
your
if you
reaction
look
to
at
that?
what they talk about, then the Purdue model, you often see a firewall attached at every level. 62443 goes a bit further. It says, hey, you should have firewalls between those. Now, this could be a single, fewer firewalls that have multiple ports and VLANs and stuff off them, but you're
Uh-huh.
using the firewall as the hardware break between these zones for sure.
Absolutely. And the thing with that is that you start bringing in a huge level of complexity because let's say these remote sites, maybe one of them was, just brought in through acquisition. It was a completely different company. Maybe they had a entirely different technology stack. That's going to be a different vendor firewall, maybe different revision levels. You've got different types of switching and all kinds of things. Even within one company, there may be, depending upon the vintage of the site, multiple different brands or manufacturers of firewalls. And so as you bring these firewalls in, there's not just the heavy lift of placing the firewalls and the expense and the time it is to plug these things in. There's also the FTE requirements of maintaining the expertise to be able to operate and maintain these firewalls across the board and do them all equally. So that if I'm trying to get the PLC over here in the bottom left to talk to a SCADA server in the middle right, I may have to pass 3 or 4 different firewalls with that traffic. And I have to know that at every one of those firewalls that I haven't somehow inadvertently opened up that traffic wider, more broadly than I wanted to. All right, let's take the next sign. So that's the problem. It's the old Swiss cheese model. It's the how do I make sure that the stars perfectly align? If you've ever tried to troubleshoot just a simple connection problem or a communication problem, the difficulties of just being able to troubleshoot, let alone be successful in implementing a new rule. So what generally happens, as Cam here has on this slide, is that somebody eventually, with no ill intent, puts an any rule in, and hey, I got it to work. Maybe I figured out what was wrong. I'm able to adjust my rules. I'll put it back. Next time that happens, what's my go-to? Any. Figure out what's wrong, try to adjust it, get it to go back, and then pretty soon, sooner or later, somebody's put an any rule in, and they've turned their expensive firewall into a really expensive and inefficient switch or router. What do you think, Cam?
Yeah, I mean, as you said, how many times has that happened when anyone's tried to put something new on, or when we've tried to do a trial at a site? The any, it's the cheat code, but it's also the cheat code that can get you banned with a hack not long after.
I worked for a number of years with a man named Joe Detzel, and he is famous for saying in all of the if all of these sites that he's been to, and he'd been to thousands of sites as a consultant, and every time he'd ever seen a data diode or something of that type of, these strong security controls that are really, really preventative, he says, I've never one time seen one hooked up long term correctly, that there is always a jumper around it. There's always something that defeats it because sooner or later somebody has to get something done. So now we're looking at this diagram with a slightly different set of eyes. How do I make this work and get some zones and conduits without just, first of all, breaking the bank, and second of all, breaking my back trying to scatter firewalls throughout this network? And so let's do it differently. What if I could say that each of these devices could talk to the thing that it needs to talk to in a way that it really never realizes that it's going through security? What if I could basically make this essentially a point-to-point secure network? Uh, we could do that between zones. We can do that between devices. But with Blast Shield, we can keep these networks very discrete. Instead of having firewalls everywhere, we're controlling the traffic based upon software-defined rules. So a logical zone and conduit. So if I have a supervisory zone, such as that the group on the left, that I want to talk to a PLC or a something like that on the right, then I can create a discrete rule that goes directly there. And I can say, all right, these three PLCs can talk to this SCADA server, but not those. I can have this security camera talk to the IT services, maybe the DVR or something like that up in the IT zone. No problem. I can do that. And I can make these discrete rules so that instead of having to route traffic by firewall rule to firewall rule to firewall rule, instead I say, I want this IP camera to talk to this server. I want this controller to talk to this SCADA server. I want this historian to get data from these two SCADA servers or these two HMIs. It's much more simple. Cam, what do you think?
Yeah, and I think to add to that a bit as well, it's not only it's more simple, but when you go back to what you're trying to accomplish with 62443, it's that I want to manage risk based upon the security vulnerabilities and basically my exposure. So in this environment, maybe as Joe said, maybe everything in the supervisory zone can talk to the control zone at a macro segmentation level because I'm just allowing the processes to flow there. But maybe I have a particular brand of PLC that's sitting in my process zone that I know has a vulnerability that could be devastating if basically it was exploited. So that specific device or that device type within my factory, as Joe said, maybe I have many of them. I can treat those at a micro segmentation and allow, for example, only a specific protocol, only from specific systems and specific users. So I can restrict that device a bit more tightly because I don't want that to be exposed, or I can, do what's often called a virtual patch, which says the protocol that's being exploited, I'm going to block that in the system so that it doesn't get exposed. So you can use that as a way to protect those high risk items. And it also, to the point that I made earlier, this is where you can do that, start slowly. Maybe I just initially all I have are macro segmentation to say supervisory talks to control and process talks to process information. So you can very much do it basically put all your devices in groups, allow those groups to talk to each other and give access to specific users. And that's all you need to do to start off with. And then as time goes on, be more specific about the protocols, maybe further break down the users that are coming into the network, as well as the things that control time of day, location. Maybe you don't want someone coming from outside the country to access that particular system. So there's a lot of different ways to manage that.
Exactly. We have a question that came in along these same lines, and I want to go ahead and address it. It was a question that about SL2, the requiring of physical segmentation between the control and the non-control zones. And I think that there certainly is some physical, whether we're talking about locked doors, that kind of thing. But as far as just absolute separation of these systems, the way the Blast Shield works is zero trust denied by default. So that when something is behind a Blast Shield security gateway, it is undiscoverable to the network. It is essentially not, it's not there as far as from the outside world's perspective. So these things are as separated as they can be. Only authenticated traffic is allowed to go through the security gateway. So we can make a very large case there of this, not just logical, but in a very real way firewall or better segmentation between these zones as well, and in between individual assets, if you go all the way down to the micro segmented standpoint.
Yeah. I mean, at the end of the day, if something has network connectivity, you right away, there is no physical segmentation possible because they have to have logical. Now you could say, I need to put a gap between the process and maybe the DMZ and other things. So there are places where you may have to put those gaps. And again, there's nothing wrong with saying within the OT network, I have logical separation. Maybe that blast wave is not allowed to connect out to the rest of the world. So I would have a physical gap, so to speak, or an air gap in that case. So you can tweak how you deploy this to meet the needs you have, or adjust to the risk levels that you think you may have. For example, if this is a power plant or a nuclear power plant, whole different things are going to apply to how you're going to manage that. So you do have that flexibility.
Absolutely.
All right. So we'll go to the next slide, which is a slightly different take on the same thing. I'll let you talk to this one, Joe.
Okay. So with the way that BlastWave operates, the BlastWave Blast Shield product, we've got the ability to do whether it's a large multi-site distribution, or whether it's in the next building, the next state, the next country, or around the world, we have got the ability to basically make all of these look, as far as the components are concerned, as though they're either in the same network, very local, because of the efficiency of Blast Shield, and we add very little negligible, if any, latency at all to the transmission. We can create these things in such a way that something that halfway around the world actually looks very local and ready and available to the system itself. We can do this, of course, through high availability, but also just the fact that we use an overlay network on top of the existing network. So things like manufacturers, if you have a manufacturer that uses the same IP address structure in every one of their installations, that's no problem for us. We use an overlay network, so we can join all of those together. And even though they might conflict natively, we can sort that out and create them to be good neighbors with each other.
Right. And what that allows you to do, when you think about by removing this, I may have a case where the SCADA engineers could see every single SCADA system across my entire network with a single rule, versus having to have 20 rules across 20 firewalls to enable that across the entire network. So again, very complicated troubleshooting. It also means that when I want to restrict someone to maybe you can access SCADA systems, but maybe only the ones in a particular geography. I've seen customer configurations we have where they have thousands of SCADA systems that are geographically organized, and specific users can either access only the things in their geography, whether it's a single site or not, but it's within their region, or they can access every single one regardless of which site they're on. So you can, just like in any good policy, I can join devices and groups of devices and users and groups of users in any way I want, in a wonderful Venn diagram that can show who can access what. And it's much easier to look at a policy and say, okay, admin users can talk to everything and engineering users, and we're going to show that in a minute. But I just want to make sure that you recognize that this can be expanded out to show across multiple sites with a single rule that these users are allowed to talk to each other, and you don't have to push individual rules down to every single firewall in your network.
Correct. Correct.
And even flat layer 2 networks, Joe. And this is something where if you're starting from scratch, this is a great tool. And I'll let Joe describe how we can take a flat layer 2 network, add Blast Shield, and suddenly zones and conduits can be created to your heart's desire.
Yeah, back to Blast Shield can go even down to layer 2, and we can technically, with a multi-port device, use MAC addresses to add endpoints into the system. Because of that, we can use our technology to take a flat layer 2 network be able to make it communicate more broadly, be able to communicate to other devices in other networks, and take that with the port isolation. And the beautiful thing about the way the port isolation works in these switches or private VLANs or whatever the technology happens to be called, it's all essentially the same. We let our gateway manage that traffic between those ports so that even in a small network or large network, we can say that this one endpoint can only talk to this other endpoint, or these 5 users can talk to these devices, but no one else, but they can't even talk to each other. All of these rules are very dynamic and flexible because they are designed to be peer-to-peer or essentially point-to-point in their nature.
So let me give some examples of this, I think, to make it very practical. So let's take some examples of who might need to talk to what. And again, remember that also different from firewalls here, it's not just a IP address range talks to this IP address range like you would in a firewall policy. What I might want to do is I want to say a specific user group. So in this case, I want to say the admin users for this OT network can talk to pretty much anything in the network. So their policy says, I have access to whatever systems I need to, because that's my job, is to make sure everything's running and the network segments are running properly. So I may need access to everything in the network. Whereas maybe another set of users, maybe the engineering users, when they connect to BlastWave, all that they can see and access in the network might be the process zones and the process information. So maybe they can only see the actual devices and the things that are running in that network from a process perspective to make sure that the actuators and the PLCs and the data story and everything is being collected and processed correctly. So not only is that all they can access, but that's all they can see. So if they did, and again, I'll invite later on for you to get a demo, if you did a port scan as an admin user, I would see everything that's connected to the green lines here. If as an engineering user, I did a port scan, I would only see the devices that allowed me to, that I was allowed to talk to if I actually allowed ICMP traffic in the network. So you can again, reduce that. You may also have something like a temporary user, a contractor who's doing maintenance. Maybe they can only access, for example, sensors, maybe they're the HVAC or something, and they're only allowed to get into that safety zone. So they cannot see and access the whole network. Anyone that's ever read up on the Target hack, which yes, it was many years ago, but an HVAC contractor was used to be the initial vector to get inside that network and cause havoc with a data breach. So all of the temporary users are typically one of the biggest challenges for zones and conduits because they need to access very specific things, but they could wreak havoc if someone steals their credentials or they get fired or the contract gets lost and you forget to revoke their privileges. You could even, for these temporary users, say you can only access the system during these hours of the day and restrict them even further. You also have cases where devices need to talk to other devices. So specific PLCs need to talk to monitoring systems to report up, or SCADA servers and controllers need to send stuff down to the actual systems that they're managing. So you could see these devices. So it doesn't have to be a person, but maybe the devices that we've created in that overlay, we want to let them talk to other specific devices. So when you think of what we described, this is zero trust segmentation. That's what this diagram, although messy and colorful, shows, is that I can be very specific about who's talking to what. There's only one policy conduit here that's created, but with the blast shield systems, you don't have to try and navigate your way through firewall policies. So it's a much easier configuration, management, and maintenance over time for that. You want to add anything to this one, Joe?
Yeah, I think the system to system. So there's 2 real big aspects of this. It's the interactive remote access that you would see maybe from the remote access over there in the top right zone. You know, the user accounts exist in BlastWave or Blast Shield, and they can get access to these things. But there's also the idea of just the system to system aspects of this, where if I am in the control zone, I can't see these other zones. I'm only, if I'm the HMI, I only have access to, a certain few PLCs or something like that. I mean, where I can really sculpt the access of each individual device in a fully implemented micro-segmented system, or even in a macro segmented or a little bit less micro segmented setup, like we're talking about with these zones and conduits. I'm controlling what each of those zones can actually see, but I'm making discrete conduits that don't require a bunch of different firewalls in between here and there. So just to echo what you were saying, Cam.
Yeah. So I think the message we want to leave with on this section is don't let the challenge or the massive workload that you think you will get with a segmentation project prevent you from starting it, because there are ways you can do this slowly, smartly, and securely. This does not require outage. This basically requires little switches of policies which happen in real time. So let's just kind of close out with some of the benefits of how a zero trust software defined segmentation can benefit your network. The first and most important is really that it does enhance security. If you isolate network segments, you are basically limiting the blast radius, which is where blast wave comes in, of a security breach. You don't want attackers, if they somehow manage to get in. So obviously with Blastwave, we have passwordless MFA that's used for access, so credentials can't be stolen, but that we may not be deployed for your remote access. So you may have people that are using passwords and credentials can be stolen. So let's make sure that the people who are coming in that don't have the highest levels of trust or don't have the most secure access are limited to only systems that can do minimal damage and basically contain that within their zone and not let them move laterally. When we talk about the techniques used by nation state hackers specifically, that living off the land and moving and hiding is a trademark of these attacks. And by segmenting your network properly, you can prevent that from happening. Joe just talked a lot about the granular control, being able to segment down to very low, not just at the device level, but the user level, the protocol, the ports. You can limit the ability of a user to make an effect. And I would think of it almost as if you're wearing if you were a medieval swordsman and you wore armor and you only had a face shield with basically a few slits in it for your eyes to see out of, your damage zone was very small, that someone had to hit a very small target to be able to affect you. What you want to do in the OT space is make that addressable target or your attack surface very small. And this is what we enable to do with our segmentation capabilities. I think one of the most important things that we have seen, and Joe can chime in after I'm done with this, is agility. We have had so many cases where we said, well, we'd like to do a trial with a customer, and they say, well, come back in 3 weeks. That's how long it takes us to do a firewall rule. And in most businesses, if you have to wait 3 weeks for a critical thing to happen, you're not going to be running a business for long. So you can literally see in our demos how, oh, you want to make a rule? I'm going to create the rule. I'm going to press the button, and literally real time, you'll see that policy take into effect. So, and oh yeah, if you mess up, you can change it right back, just like that too. It doesn't have to be all day. I mean, you can comment on this one, Joe, because you've heard this every time we go to talk to someone to do a trial who has firewalls on the network.
I've not just heard it, I've lived it. As an EMS development supervisor, we ran a very large energy management system, and there were multiple teams all around us that we required, or we had to have their aid in order to implement anything. The database management team, the firewall management team, the WAN communications team, the servers team, sometimes even down to the desktop team, or into the operations center itself and the supervisor, the operator. I mean, every one of these teams might have their timeline that we have to wait on to get to that next step as the EMS team. Now, with Blast Shield, if I was able to do that kind of thing when I was doing that, that would have significantly made sped up every one of our development process. We were going to test a rule, if we were going to test a new connection, ICCP or something like that, to a different site, we could test the rule almost instantaneously through Blast Shield, see if it was working, get it working, and be done with it. Just a few mouse clicks, so much easier to operate.
Yeah, and I forgot to admit this before, but I'll add it now. Let's say you add a new device to your OT network. In the Blast Shield model, I basically say, I'm going to take that device, I'm going to add it to the PLC group, for example, and that device now inherits all of the properties that the PLC group has. So it can talk to the right servers, it can talk to the right users. So just by making it as part of that group, I've finished. I don't need to draw a pass through my network for that device for everything. I don't need to map out what firewalls need to do. It happens automatically. So that increased agility is not just for things like that. It's as I expand my network, that ongoing maintenance of how do I keep my security common happens very easily with our system. And then again, that management, we recognize fundamentally that not all OT cybersecurity people are security engineers who are certified by everything. They may be new. In fact, the SANS report that came out, so I think it was over 50% of the people in OT security had been in the job in less than 5 years. So there's a lot of people that are new or haven't done this a lot, or in some cases, it's a part-time job. So if you make this hard and complicated, that any rule that we talked about earlier is going to be a problem because it's going to be the de facto way to operate. And anyone that's ever worked in a operational network knows that if something starts to stop the network from working, we're going to find a way to bypass it. Whether that is physical bypass, whether that's logical bypass, or whether it's I'm going to connect another port to the back of that computer so that I can access it no matter where I am, they're going to find a way. So you have to keep it simple, or people will find a way to create risks that you don't even know about, which is even worse for you as a user and an administrator. And then finally, cost. The cost of implementing a solution is not always just the hardware and software and the support contract that you buy. It's people, it is time, it is resources to learn those systems. And then there's the actual cost and maintenance of those systems. So doing this in software rather than buying 50 firewalls and the support contracts. I mean, we've seen cases where we're a tenth the cost all the way up to a quarter of the cost for those. So this software-defined system allows you to do this much more cost effectively, as well as manage it and keep the cost down of operation. So if this sounds too good to be true, we like hearing that because it means that we have something that would be interesting. So if you do and are interested in hearing more about this, obviously you can come check out Blastwave. If you have questions, there's my email address. Feel free to reach out to me. We like hearing it's too good to be true because that means that it sounds like it could be helpful. We do think that our system will help you do your job better as an OT professional. And our mission in life, if I put on my dark sunglasses and said I was in the Blues Brothers and said our mission from God is to help OT, that's what we're here for. So if you're interested, feel free to reach out.